Take 3. All right. So this is just going to be a short, hopefully very gentle introduction to really basic statistical symbolism for those people who maybe are brand new to statistics and are a little intimidated maybe about looking at equations and understanding those equations and what they're telling us to do in terms of data, in terms of calculating the statistics. So this will be very brief, and I'll probably refer back to this video in future videos where I do introduce equations. I'll remind you of what all the symbols mean and stuff, and I'll always walk you through equations when I first introduce them. All right, but let's get started. As soon as I can make this advance, there we go. Okay, so you know that typically we represent data with letters like X that just sort of stand in for a number. This is way back to beginning algebra, that idea. So suppose I ask you how old you are. You might say any crazy thing. Who knows what you'll say? So your answer is a variable, and I can label that variable with an X. Especially before I know what you're going to say, I can still represent what you're going to say with this variable X. But now suppose I want to go further and I want to ask 10 different people their ages. Well, I could use 10 different letters, but that's going to get cumbersome really quick. In fact, after 26, I'm going to have to start using double letters and so on. That's just going to become very cumbersome and hard to keep track of. So instead, I'll just use X for every single person that I ask, but I will then use a subscript on that X to denote which X it is that I'm talking about. And typically I'm going to use something like the small letter I. Once I have to subscript several different things, I might use I, J, and K as different letters to stand in for the subscript, and so on. And really the subscript is just another variable, right? So here's an example of how this works. So X sub I, the totally generic version, stands for the ith observation or the ith datum, right? And that is how you say it, the ith. And we read that X sub I. And then a couple of examples where we actually fill in the I so that we're referring now to a specific datum. X sub 1, that's the first observation, or more generally the observation or measurement, that's another word we can use, of subject 1. Participant 1, observation 1, whatever you want to call it. X sub 7, that would refer to the 7th observation in the data set, or the datum from subject 7, and so on. Okay, so that's usually a little bit more convenient than using multiple letters and double letters and so on to use a unique set of letters to represent every participant's variable answer. We're just going to use a single letter like X. Sometimes we'll use Y, sometimes A or B, but we'll pick a single letter and we'll stick to that letter, and we'll use a subscript to refer to the particular datum that we're referring to, the particular observation of the X variable. All right, and really the main other thing you need to know to understand 90% of statistics equations is this symbol right here, the sigma. And this Greek letter, this is capital Greek sigma, just means the sum of. So let me turn on my laser here so I can point. Nope, that didn't turn it on. Oh, there we go, laser pointer. There we go, there's my laser. So this symbol right here has the sigma in it, and that sigma just means to add up all of the X sub i's from this starting point here to this ending point right here. And you would read it, the sum from I equals 1 to n of X sub I. That's how this thing right here would be read, the sum from I equals 1 to n of X sub I. And you can see here the formula for that, and that's just telling you take all your X's, X sub 1, X sub 2, etc., all the way up to the last X. Big N here is another variable. It just stands for the number of observations you have. And you're going to add up all the X's to X sub N, the number that you have. Now, sometimes you will see just the sigma and the X sub I. You will not see the I equals 1 or the N. And that's just telling you when you don't see anything above or below, that tells you to assume that you're going to add all of them up. Just assume that it means add everything in the set. All right? And let's try a couple just for practice. So you might want to write these down if you have some scratch paper nearby and a pen or pencil, and stop the video, try to do these, and then come back and see if you got it right. So just try this one. All right, you stopped the video. I'm sure you did this. and so you should have gotten 43 for that one. And of course, that's just add them all up together. Add up every number in that set. Let's try this one. Stop the video, try to add this up, see if you got it right. All right, and if you did that, you should have added up. This is the sum from I equals 2 to 3 of x sub I. And so the I equals 2, that means the second observation. That would be this 7 right here. X3, the third observation, that would be this 2 right here. And so you would have added 7 and 2 and gotten 9. All right. And now this is the last thing I'm going to talk about in this video, so we'll make this a really short, sweet video. Basically, we tend to, in statistics and in the social sciences where we use statistics, use different symbols for population parameters and for sample statistics. So a population parameter and a sample statistic are exactly the same thing mathematically. What makes them different is just what data you're calculating these numbers on. When you have population data, that means you have data on every single person or animal or city or whatever it is your population you're studying, whatever population you're interested in, you have data on every single one of them. Then you're calculating population parameters. You can calculate the population parameter mean, variance, standard deviation, and so on. When you don't have data on every single member of the population, then you have some subset of the population to call a sample, and then you're calculating sample statistics. Now, sometimes I said they were exactly the same. That's not quite true because, for example, these two are slightly different. They're calculated in a slightly different way for a reason I'll get into in the video where I cover the measures of variability. But here we're just talking about their symbols. So the symbol for the population parameter mean is the Greek letter mu, and for the sample statistic mean we use either an M or usually some letter, often it's X, not always X, but often it's X, with a bar above it, and we read it just X bar. So this is called X bar. So M or X bar, either of those could refer to the sample mean. Mu refers to the population mean. Little s squared refers to the sample variance. Greek letter sigma squared refers to the population variance. And because standard deviation is just the square root of the variance, standard deviation, sample standard deviation is represented with just s, population standard deviation with Greek letter sigma. All right, so that's just a very brief, hopefully watered down introduction to statistical symbols, and that will give you some background to start understanding things like the equation for the mean, the equation for the sums of squared deviations about the mean, standard deviation, all that kind of stuff, which we'll get into in later videos.